All right, so we're going to find the inverse and state the domain of a rational function. So the thing that makes this a rational function is the fact that you've got a variable going on here in the denominator. All right, these are going to be I don't know. The domain part's probably a little bit more straightforward, but the rest of it might be a little bit more algebra than you wanted. Anyway, here we go. We're going to start by swapping the x and the y. So I get x equals 3 over y plus 4. Now the trick here is that we want to solve for y, so I need to get this whole thing out of the denominator. So what I'm going to do is I'm going to multiply both sides of the equation by y plus 4. So multiply by y plus 4 right there. All right, that's going to get the y plus 4 out of the denominator. Okay. So I'm going to have a 3 on that side, and then I guess I can keep here. I'll distribute my x, so it's going to be xy, and then x times 4 will be 4x. Got it. And to solve for y, we're just going to move that 4x over to the right side. Move that 4x over. So I get xy is equal to negative 4x plus 3. And then last, divide by x. Yeah, divide by x, divide by x. And there you have it. That's our inverse. It's y is equal to negative 4x plus 3 over x. All right. Now to state the domain, on square roots, you weren't allowed to have any negatives under the square root as your final answer. The way it works with rational functions, the only thing you have to avoid is that denominator ever equaling 0. You know how you can't divide by 0? That's the thing that you have to try to avoid here. So in this case, the only number that we cannot plug in for x is 0 itself. That's the only number that would give us a 0 in the bottom. All right. So the domain here, it's going to be all numbers except for 0. All right. That's going to be our domain. All right. That's the one number that would cause the denominator to equal 0. All right, here I wanted to pull up the graphs here since we haven't seen we haven't seen any actually of these rational functions. I think we mentioned the parent function once upon a time, but the red one is the original, and so you'll notice on the original you can't plug in negative 4 for x. So here at negative 4, what happens is that the graph kind of blows up. Right? It has they call this an asymptote. It has an asymptote at negative 4. And so the function actually never crosses that. It never gets to it. And what that means, all right, if the function never, well, no, I'm not going to mess with that. But on the black function, the one that we were interested in, the domain of the inverse, the black function, the same thing's going on there, but it never crosses 0. We said that the only number you can't plug into the function was 0, and that's the idea right there. All right. Let's go ahead and we'll do one more of the rational functions here. All right, we're going to do y equals negative 2x over 2x minus 3. All right, swap the x and the y. This time we have 2x's here. I'll show you how we do that. So that means we're going to have 2 y's when we make our swap. So we'll have negative 2y, and on the bottom we'll have 2y minus 3. All right, so again, we're going to multiply. Oh, man, I should have moved this over. Actually, I am going to move it over a little bit. All right, so swap the x and the y. We're going to have x on the left and negative 2y there, and a 2y minus 3. All right, so the first thing we want to do is clear the denominator, is get our 2y minus 3 out of the denominator. So multiply both sides by 2y minus 3. And we'll multiply this by 2y minus 3 as well. Okay, so these will cancel. And so you're left with negative 2y on the right side, and then we'll distribute our x in on the left side. So it's a 2xy minus 3x. So the way we're going to handle this, because there's two y's that we're trying to get the y by itself, but we have two y's. We need to get all of our y's on one side, and everything that's not a y on the other side. So I'm going to swap these two here. I'm going to add 2y to both sides. So it's a 2xy plus 2y. So I'm plussing 2y to both sides. And I'm also going to move that 3x over to the right side. So it becomes a positive 3x over there. So the way that you get the y by itself here, because both terms have a y, you're going to factor out a y. All right. So factor out a y. This first term is going to become a 2x. And then the second term is going to become a 2. All right. Hopefully you see that if you kind of distributed the y back in, you would get right back to where you came from. All right. That's the idea. All right. Now that the y is it's a factor, it's connected by multiplication. Now I can divide by this 2x plus 2 and get rid of it. 2x plus 2. 2x plus 2. And so there we have it. Y is equal to 3x over 2x plus 2. Okay, on our domain. So the only thing we want to avoid here is the denominator blowing up. There's one number that could be plugged in for x that we have to avoid. You might already see what it is. Looks like it is -1. You cannot plug in -1. The way you figure that out is you just take that denominator, the 2x plus 2, you set that equal to 0 and you solve for x. Move the 2 over and then divide by 2. Divide by 2. And you get x is equal to -1. This is the one number that you are not going to be able to plug in for x. All right? So the domain is going to be all numbers, all real numbers, except for x equal -1. I'll just circle the whole thing there. Cool. All right, there's some rational functions, and we're good.